With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, so question is saying this: the enthalpy of evaporation of water at 373 Kelvin is 40.67 kilojoule per mole. And what will be the enthalpy of evaporation at these two temperatures, that is 353 Kelvin and 393 Kelvin, if the average molar heat at constant pressure, that means it is Cp, in this temperature range for a water in liquid and vapor state, that is we have the value 75.312 and 33.89 joule per Kelvin per mole. So let us try to solve this question and find out the value of enthalpy at these two temperatures. So we have given the temperature T1, that is we have given that is 373 Kelvin, and at this temperature we have the enthalpy of evaporation, that is 40.67 kilojoule per mole, right? So if you convert into joule per mole, so you will be you have to multiply it in 10 to power 3, so you will get 40670 joule per mole, right? And for calculating the enthalpy of evaporation to temperature, so we have the formula. The formula, as you can see here, this is delta H2 minus delta H1 is equals to delta Cp, the change in, you can say, specific heat capacity at constant pressure, right? So and T2 minus T1, right? So this is the temperature, this is the formula for by which we can calculate the enthalpy of evaporation at two temperature, right? So now you can see here we have to calculate it, this value. So you can see here, this is delta H2 equation becomes like this, delta H1 plus delta Cp. So you may write like this. So this Cp for water liquid, right? So water into gases, right? So because here we have the equation like this, water is in liquid state, it is converting into vapor state, that is gaseous state, right? So the change will be gaseous minus liquid, right? So because this gases has a, you can say, the more heat capacity, no, you can say the more value, right? So final minus initial, right? So we how to find the change, we will final minus initial, right? So we'll do like this. So this will be H2O gas minus Cp H2O liquid, right? So it will be Cp H2O liquid, right? So this will be the value, and here we have the temperature, that is T2 minus T1, right? So here this is the temperature range, T2 minus T1, right? So now you have to do nothing, you have to put the value here and you will get the enthalpy of evaporation, right? So now you can see here at 353 Kelvin. So let's try to find out at 353 Kelvin. So you can see here delta H2 will be equals to, here you will see this delta H1 will is 40670, that is 40670 joule per mole, plus you can see here this value is, the value for this gaseous state is like this, you can see here, this is for 33, right? So I can write here this is 33.89, and for liquid this is 75, right? So I can write this is 75.312, right? So this is 312, right? And for the different temperature, T2 temperature, this is our temperature T2, right? So you can say this is our temperature T2, right? So and this is our temperature T1. So temperature T2 is 353, so it is 353 minus 373. So if you further solve it, so you will get the value, right? So you, when you solve it, so delta H2 comes out to be 40670, right? So and when you solve it, so it is equals to, when you minus it, that is, you can see here the minus 33.89 minus 75.312, right? So this is 75.312, so it comes out to be minus 41.422, right? And this is the value, you can see here, this is the value minus 20, right? So this is the value minus 20, right? So when you further solve it, so you will get 4, and all the value are, you can see this in joule per mole, right? So this is joule per mole, right? So 40670, and this becomes plus, when you multiply it by 20, so you will get here 828.4, right? So 828.44, and that comes out to be, you can see here, when you add it 40670, so that comes out to be value approximate 4198, right? So approximate this value. So if you, for clarification, I will add it 40670 plus 828.44, right? So this value comes out to be 41498.44, right? So 0.44 joule per mole, right? So this is the enthalpy of evaporation at this temperature, right? Similarly, we will find the enthalpy of evaporation for 393 Kelvin, right? So let's try to solve it. So you can see here, for this enthalpy of evaporation at T2 is equal to 393 Kelvin, right? So I can write here 393 Kelvin, right? So you will do nothing, just you have to replace this 353 just by 393 and you will get the value, right? So now you can see here the value becomes delta H2, right? So this is delta H2, which is equals to here 40670, right? So all value becomes the same, right? So you can see here I am just writing the directly. So you can see here just we have this value same, right? So I'm just, you can see here this is value 333.89 minus 75.312 and here you will get 393 minus 373, right? So you will get here 40670 plus, you can see here the value becomes here, that is minus 41.422, right? And here you will get the plus 20, right? So here you will get plus 20, right? So now when you further solve it, so you will get the value will be like this 40670. When you multiply it, so it comes out to be 828.4. just as a difference of just sign, right? So and this is equals to joule per mole, right? So this is equal to joule per mole. So when you minus it, 40670 minus 828.44, so the value becomes 39841.56 joule per mole, right? So this is the enthalpy of evaporation at two temperature, right? So at 393 Kelvin, we have this value, right? So at 393 Kelvin we have this value, and you can see this, and at 353 Kelvin, we have this value, right? So we have this value 41498, right? So in this way I can see this, we have calculated the value of enthalpy of evaporation for at two different temperature, right? So hope this answered your question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.